EMI, the European Middleware Initiative, is a software development project coordinated by CERN, involving 26 partners in 18 countries. The 4 major European providers of software for distributed computing join their forces in EMI to create a single, efficient software distribution for scientific applications. The EMI software services were fundamental in enabling the Higgs Boson discovery. How did that happen? The search for particles like the Higgs boson starts at CERN in the Large Hadron Collider, or LHC. The LHC accelerates heavyweight particles close to the speed of light. They are then smashed against each other at 4 points of the LHC, inside giant machines called detectors. As the debris of the collisions are scattered around, their paths are registered by the detectors. The experiments hosting the detectors filter the data and then send it to the CERN data center, where it is aggregated, reconstructed, and stored. Data generated at CERN by the LHC is then distributed across the worldwide LHC computing grid, or WLCG infrastructure. It is first sent to 11 computing and storage sites in Europe, USA, Canada, and Taiwan. Data is transferred using the FTS service and stored in 3 different types of storage systems maintained by EMI: Dcache, DPM, and Storm. The 11 sites further distribute subsets of the data to more than 150 sites worldwide. That way, scientists from hundreds of universities and research centers can easily access the data. Physicists from around the world can submit computational jobs to the grid. A job is a program that analyzes the data to understand what happened during the collisions produced by the LHC inside the detectors. Grid certificates are like virtual passports issued by the research institutes to their researchers to authorize them to submit jobs to the grid. The scientists send the jobs directly from their computers. They select either directly one of the hundreds of the grid computer centers or send the job to workload management systems, like the WMS. The best possible site for the job is located using services like BDII or EMIR, databases of information about the available sites and their computational capabilities. Each grid site provides storage and computing to 1 or more scientific communities like high-energy physics, life sciences, neurosciences, or earth and environmental sciences. The queues of jobs coming into the site are managed by EMI services like CREAM, ArcArex, or Unicore. These EMI services act as traffic hubs for the grid site. They dispatch jobs to available computers and monitor their status. Once authorized by the Argus Policy Service, the jobs are executed on a local computer and run within secure, isolated areas called sandboxes. Security is of key importance and is monitored in all grid services. The data to be analyzed by each job is located using file catalogs like the LFC. The files are prepared before the job is executed or are dynamically accessed during the job using the EMI Worked Node software. Finally, data generated by the job is stored so that the physicists submitting the jobs can find them later. Millions of jobs are executed 24 hours a day over WLCG in a continuous stream of data and calculations that never stops. As the data produced is combined and consolidated, evidence of the new discovery can statistically take shape until it actually becomes a scientific certainty. The news of the discovery of a Higgs boson candidate was announced by the CERN Director General and the CMS and ATLAS experiment spokespersons on July 4, 2012, and confirmed in March 2013. The computing grid was one of the fundamental elements in the discovery.
The results today are only possible because of the extraordinary performance of the accelerators, including the infrastructure, the experiments, and the grid computer. I think this was key or is key to the success.